Owen's bridge. Owen's bridge is an AC bridge circuit used in the electrical measurement to determine the unknown inductance in terms of known resistance and capacitance. It's basically work on the comparison principle. When the balancing the unknown inductance against the standard capacitance, it allows the by using specific bridge circuit equation, you can find precisely the unknown value. So here is the circuit diagram of the Wheatstone bridge. It contains 4 arms. Arm 1 contains inductor in series with the resistor. Arm 2 contains capacitor in series with the resistor, and arm 3 contains resistor, and arm 4 contains only capacitor. So here we will give the AC supply because it is a AC bridge. As arm 1 contains inductor in series with the resistor, so Z1 will become R1 plus J omega L1. Arm 2 contains resistance in series with the capacitor, so Z2 will become R2 plus 1 upon J omega C2. Z3 equals to R3 because of only resistance, and Z4 equals to 1 upon J omega C4 because of only capacitor. So at balance condition, what will be the equation? Z1 Z4 equals to Z2 Z3. By putting the value of Z1 Z2 Z3 and Z4 in the equation, we will find the value of R1 and L1. So by putting the value, so by multiplying this with the bracket, we'll get R1 by J omega C4 plus L2 by C4 equals to R2 R3 plus R3 by J omega C2. By comparing the real and imaginary part, on both the sides, so L2 will be R2 R3 into C4, and R1 equals to R3 C4 by C2. Now we'll see the vector diagram. So vector diagram. So I1 R1 drop will be on x-axis because of inductance. I1 with J omega L1 will be 90 degree lagging. It is on y-axis. I1 J omega L1. We will get the E1. E1 and E2 both are equal of value. On the other hand, I2 R2 drop will be on y-axis. So resistance is parallel in series with the capacitors. Because of capacitance, it is 90 degree leading. So I2 by J omega C2 will be 90 degree leading. In same phase, we will get E3, which is I3 R3 drop. E3 equals to E4 equals to I4 by J omega C4. So by law of parallelogram, we will get the resultant vector of E. So resultant vector E is In this phase, here I2 equals to I4 and I3 equals to I1. Because in series current is same, when you refer the circuit diagram, you will find I3 and I1 have same value, and I2 is the same current which flowing through the branch I4. So again, by law of parallelogram, we will find the value of resultant current I. This current I is lead because of capacitance in the circuit.